Okay, guys, let's get started. Um, Welcome to Moi Builders 6. I'm Aditya, or you can call me Adi. I work for the ecosystem team at Server Labs. So today is going to be a hands-on session. We're going to essentially open the repo. You can follow along or you can code along. Today's promise is very very simple. We're going to give an AI agent its own identity on chain. We're going to give it an address, a budget, a ledger from one wallet in one transaction, and we're going to build everything live. Yeah, and before I get started, for those who are new over here, a quick intro about myself. Like I said, I work in the ecosystem team at Server Labs. I'm essentially the DevRel. So any kind of questions related to building, if you guys want to explore any opportunities with Moi, I'm the person you should essentially talk to. Nice to meet whoever's new today, and thanks for joining again. Once those who already here. And yeah, let's get started. So let's start with the problem that you all will recognize if you've built with AI agents in the past. So say you're running a few AI agents. One does research, one does trades, one scrapes data, and they all share just one wallet. Now I ask you a simple question: which agent spent what last Tuesday? Actually, take a second and think about it. Um, with one shared wallet, you generally cannot answer that. Let's break into three specific gaps. First, no attribution. Every action any agent takes comes from the same address. So nothing on chain. It's like everything on chain is just one big blur. You can't essentially tell them apart. Second, there's no per context budget. So there's no ceiling, no so any single agent, buggy, misled, rogue, whatever, can drain the whole wallet if it's if it would like to. Third, there's no isolation, and this is the most important one. Agents share everything, so one bad agent's blast radius is your entire like wallet balance. So our goal for the session today is to fix all three, give each agent its own identity, its own spending limit, and its own ledger without creating and funding a brand new wallet and seed trace for every single agent. Uh, the feature that lets us do this is called context inheritance on Moi. Okay, so this is the most important idea in this whole talk. So let's go a little slowly, and feel free to drop any questions along the way. On most chains, you're used to a contract that keeps a big table inside itself. Something like address X has balance Y, and everyone's data lives in that one shared table. In most cases, it's a mapping. Moi does the exact opposite. On Moi, a logic, which is just Moi's word for a smart contract, keeps no table of its users. Instead, each account carries its own piece of that app's data, if that makes sense. We call that per account data as active state. So here's an analogy to hold on to. Think of the app as a gym. On a chain like Ethereum, the gym keeps one big binder with every member's info inside the gym. On Moi, there's no binder as such. Instead, each member gets their own locker and their info lives inside their own lockers. The gym can only store your stuff if you've first been given a locker. So the three steps on the slide. Step one, which is your primary account, the one from your mnemonic, your seed phrase, the one which you get when you create your first existence on Moi. It holds funds and manages everything. Step two, you can inherit a sub account. Um, that's one single transaction called account inherit that creates a new sub account and links to a specific logic. Step three, because of that link, the sub account now has its own active state slot under that logic. So it can finally call the logic's endpoints as itself. Now, the key question, the one a developer here is already thinking, like, why do I need this extra inherit step at all? On Ethereum, I just call the contract. The answer is exactly the locker itself. On Moi, the contract has no binder to write into, so your account needs its own locker first. A brand new account doesn't have one. So if just to confirm, you'd like to call and need it. Sorry, guys, my Siri activated for some reason. Yeah, I was saying. So the answer is exactly the locker itself. On Moi, the contract itself doesn't have a binder to write onto. So your account needs its own locker first. A brand new account doesn't have one, so if it tries to call the app, there's nowhere to actually store the data and the call fails. Inheriting is what creates this locker and creates that isolation that connects to your primary wallet in the first place. So I'm going to stop for a minute over there in case anyone has any questions. Okay, let's keep moving. If like always, if anyone has any questions, the chat's always open for you guys. And yeah, so the second big idea, and this is what makes the whole thing practical, is when you create a sub account on Moi, its address isn't random and it isn't handed out by a registry. It's computed. So specifically, a sub account's address is the primary's first 28 bytes plus 4-byte index number stuck on the end. So look at the three rows on the slide. The primary ends in 0000. Sub account is one is the exact same long prefix, just ending in one. Sub account two ends in two, and they're on the fourth. And this matters just because it means anybody, including the agent itself, can figure out the address of the sub account number, and with just pure arithmetic, no database to look it up in, and no config file to store it in. The only thing you can't compute is the subaccount status. Has it been inherited under logic yet or not? And that's a single cheap read from the chain called get context info, which we'll get into in some time. For the AI builders in the room, that's essentially the punchline. An agent can discover its own on-chain identity with just a bit of arithmetic and one network call. Zero infrastructure to stand up, and that property is what the entire demo is built on. Okay, so I know there was a lot of theory over there, but that's going to end real quick. We're going to start with the demo real soon. Before we do that, let me just lay out the landscape. So, quick map before we open a single file. So, nothing you see next looks cold. The whole repo is just two halves essentially, and this slide shows both. The first half is on chain and is exactly one file. We have agent.budget.coco. And once again, for those who are new, Coco is our context aware programming language. It's like Moi's native smart contract programming language that enables you to have participant centric um, computation. So that's the logic. It's about 90 lines that stores each agent's budget and spend total and enforces the cap. It's the only thing we ever deployed to a blockchain. Nothing else in this repo gets deployed. The second half is the driver itself, a small node command line program that runs on your own machine and talks to that one contract. Deploy budget.js is the one-time script that puts the contract on chain. We've discussed this in previous sessions as well. We have an SDK that essentially allows you to, which wraps around your smart contracts and allows you to deploy on chain with just like 2 to 3 lines of code. So that's what deploy budget.js is. Um, and Yeah, then we have squad.js, which is essentially the start of the show. It holds all four commands we'll use today. So, provisioning an agent, spend, run, and report. Uh, Agent.js is an alternative, more conversational demo, which we're not going to be covering today, but it's going to be on the repo live if you guys want to check it out yourself later. And yeah, finally, lib is just the plumbing underneath, building wallets, making the get context info calls, um, and doing the address math we just saw. The one thing to take away from the slide, only one file lives on chain. Everything else is just a client that computes addresses and reads state. No server, no database, no registry anywhere. So yeah, let's start with the first contract then. This is essentially the first piece of code you're going to be seeing today, the actual contracts that our agents will be calling into. And good news, it's only about 90 lines total. It's not too big, and a lot of them are also just comments. Um, and Yeah, and we only need to essentially understand three pieces of it, and I'll take them one piece at a time. So follow along and drop any questions, or feel free to ask me to pause at any point. So piece one, which is the state. Um, Look at state act. Yeah, so the word actor is the important one. It means that the state is per account. Every inherited account gets its own budget and its own spent value. Um, and There's no global list of users anywhere in this file. If 10 agents use this contract, that's 10 separate little budget spent pairs, each living on its own account, not in like a global mapping. And this is the locker idea we spoke about earlier. Now in real code, piece two, which is the one that matters, is endpoint dynamic record spend. So what this essentially does, this is the endpoint an agent calls every time it spends. Now let's walk through what it does from top to bottom. So it first reads the account's current budget and current spend. It computes next as spend plus the new amount. And the crucial line, if next is greater than the total budget, it throws an error and the entire transaction is rejected. And notice the most important point is notice where that check actually lives. Lives inside the contract running on the blockchain. The app itself never checks anything, or the agent itself, yeah, it never checks anything. It's fully enforced on chain. So two things to say clearly, and they're worth repeating. First, because the state is per account. Only an account that's been inherited under this logic can even call record spend, and there's no locker, no global state. So inheritance isn't just a nicety. It's kind of like the entry ticket. Second, the spending cap belongs to the contract, not to my app. And hold on to that because the two, like in a couple of steps from now, you'll actually watch a real transaction get rejected by this exact line. Now, people always ask, how does an AI agent actually call this? It doesn't write blockchain code. We've essentially given the agent a tool, literally a function called record spend, where when the agent decides to spend, it calls this tool with an amount and a memo, and our code turns that tool call into like an on-chain record spend signed by that own agent sub account. So reading its balance works the same way through a check budget tool that maps to like a get budget function. And yeah, record spend is the only is the thing on the other end of the agent's tool call essentially. And yeah, so we have record spend, we have state actor, we also have set budget, which is essentially the function or the endpoint that the user would call when initially deploying the agent, along like initially inheriting the sub account for that particular agent. You can list as anything. You can say budget's 500,000. This is just a figurative demo. um, the potential use cases are a lot more. And then you also have a simple get budget. So essentially, this Coco contract only has three functions, so three endpoints: get budget, set budget, and record spend. But the most important point is the fact that it's state actor, so no goal mapping. Every um, piece of attribute of the agent lives with the participant itself, like the agent sub account. So I'm going to stop there for 30 seconds or for 20 seconds in case you guys have any questions. Let's keep going then. So we're going to start with our first demo. And yeah, so what I'm going to do. So yeah, before I get into the demo itself, a couple of things to remember for those who are new is um, we have sessions in the past where we've spoken about Coco, we've spoken about the MOI SDK. So if you guys want to go check that out, let me know and I could share the links with you, or it's going to be up on our YouTube very soon as well. But the first thing you do with any Coco logic is obviously you deploy it. So I'm going to go into budget logic and then hit Coco compile. And that's compiled. I got my JSON file out here. And the next thing I'm going to do is I'm going to deploy this on chain. So I'm not going to get into details of this because we've covered this in previous sessions, but this is essentially what our using our SDK looks like. A lot of it is boilerplate stuff. So imports are all boilerplate. Connecting the wallet is connecting, like importing the wallet package is all boilerplate. But the most important piece of code to actually deploy any custom logic is just the logic factory. And yeah, it's effectively just 2 to 3 lines of code to deploy a logic on chain. So I'm gonna hit node deploy.js. Just give it a sec. Yep, perfect. It's been uploaded. I'm gonna stop sharing my screen just for a second while I switch to the and So the next step is to essentially add this logic ID to my environment variables, because this is what this logic ID is what is on chain, is existing, and is what each time we deploy an agent, this is what it's going to inherit. So I'm going to stop sharing my screen for a second so I don't accidentally expose my environment variables. But I can show you guys like a example of what that looks like. Yeah, we're back. This is essentially what the environment file looks like. Um, I mean, there's a lot of stuff that you don't have to do over here, but essentially the most important is, use a mnemonic in the derivation path. Sub ID and account will come later as well. For the agent.js, like the more live agent demo I was telling you about, conversational agent demo I was telling you about, that's what the Anthropic API key is for. You can try it out if you want to. You don't have to if you don't want to. But again, the most important point is that you put the logic ID over here, because in the next files that we'll walk through, the agent that's creating the sub account is going to inherit this particular logic. So yeah, let's get back into the demo then. Oh, yeah. So this is essentially where everything's going to click. What I'm going to do is I'm going to run node squad.js provision trader 500. Now, before I hit enter, I am going to explain what all this is. And also, we are going to, once we do this demo, we are also going to walk to squad.js. Um, but this is actually one command. Um, and in plain English, that's what we're trying to do over here is just create an agent called trader and give it a budget of 500. Provision is just a function that we call within the like the function I've created to essentially like add that budget to that trade that agent. So I'm going to hit enter, and the most important point over here is this is my primary account, right? This is my wallet that I've connected, like my official my wallet, um, and this is a sub account it's actually created. And to actually see this in real time, I'm going to copy this sub account's address. You can see it has a budget of 500. And keep in mind over here, where does it? Yeah, it says account inherit, create, plus link to logic, plus seed 60,000 KMI for gas. Now, I'm going to go into Voyage and show you guys that with one deployment, it's actually created a sub account with basically the same address as mine except the last digit, and it's actually given a 60,000 KMI. So, and once again, for those who are new, Voyage is our, it's kind of like our Ether scan. You can see all our transactions. You can see all your transactions, your testnet faucet. You have a bunch of stuff like asset playground, logic playground, which we've covered in previous sessions. But I'm gonna paste this participant's address, and there you go. You can see that this sub account has 59,663 KMI. Would have just lost a bit now in the transaction itself. Um, but yeah, this is live proof that a sub account actually exists on chain. Um, so yeah, so now that that's done, I'm also just going to walk through what each of these means. So step one is derive. Before we touch the chain at all, we have to compute the subaccount's address using the math from earlier. So primary prefix plus the index, no transaction yet. This is just pure arithmetic. So this is what I was talking about. You have my address and my address plus 4. Step two is account inherit. Um, this is the one real transaction, and it does three things at once. It creates a sub account, it links that account to our agent budget logic. That's what gives it a locker, and it seeds with a tiny bit of KMOI so the agent can actually pay with its own gas later. Step three is verification. We don't just assume it worked. We you know we call get context info, which is again something I'll show you on the file. Um, and confirm that the account is actually linked to the logic, because a transaction receipt landing is not the same as it succeeding. And finally, step four is setting the budget. Now that the locker exists, we write 500 into it and point at two addresses on the screen. um yeah, so Yeah. So that's essentially what has happened in this demo from Node Squad .js provision trader 500. We've just created an agent named trader, provisioned it, like deployed it on as a sub account of like given it a sub account under my initial wallet and given it a budget of $500. So the next thing I'm going to do is I'm going to open squad.js and show you guys the provision function I've been talking about. Again, a lot of this code is it's not much code, just a lot of comments and a lot of like fillers and not fillers but like helpers. The first thing I'm going to do is head with the provision function. Mm, oh yeah, there we are. Yeah, so this is essentially the heart of the account inherit call. Around line 169. Um, so dot target points at the logic ID. We already, yeah, 166. Sorry, we yeah, this dot target points at the exact logic ID that we deployed on chain, and yeah, so this is essentially a reference to the existing contract. We're not deploying anything again. Dot index picks up the sub account's number, and dot value seeds the little bit of gas that we want to seed. All three things happen inside the one transaction, and then just looking for, yeah. Then we have get context info. Um, so we call this and check that the link actually landed before moving on to setting the budget. That verify before you trust receipt habit is worth um, you know emphasizing on, because now you can actually see that there is a real sub account that's been created on chain, and then we're setting the budget. And Yeah, so that's essentially the first part of the demo. I'm going to again stop for 20 seconds. Let me know if you guys have any questions. But what we essentially showed here is we've created an agent, given it a budget, and provenance it on chain. Sorry if today is a bit of a long session. This is a pretty dense topic that it's very useful. Can do a lot of different things with this. Probably the most like unique USP of what we offer here at MOI. But Yeah. Anyways, let's get back into the session then. Yeah. Okay. So next part of the demo. um, so first thing we did was we instantiated the agent and gave it a sub account. The next thing we're going to do is make it spend some money. Keep in mind, this is not like, for the sake of this demo, it's not linked to any actual asset at this point. We're only assessing authority. We're not assessing actual asset movement over here. So the first thing we're going to do is node squad.js spend trader 40. So remember, we gave it a budget of 500 earlier. We're just spending 40 now. Yep, there we go. So the part I want you to see is our trader has a budget of 500. First, I spent 40, and that goes through fine. 40 out of 500 is used. And now I'm going to do something interesting to show you guys like where actually this enforcement is happening. We have a budget of 460 remaining, and I'm going to ask you to spend 500 with the explicit purpose of having it fail. Yep, there you go. The on-chain call failed. Spend 500 exceeds the remaining budget. Um, sit with that for a second, because this is the whole point of the talk. The blockchain itself refused the transaction. I did not write an if statement in my app that says, stop if over budget. My app just asked to spend, and the contract said no. The agent asked to spend, and the contract said no. The blockchain itself said no. That's the difference between a limit, you hope your code remembers to enforce, and a limit that's actually enforced no matter what the code is calling it. And yeah, the next part of the demo is gonna. I actually had a different demo in mind where I would have a live like web search agent, but that requires some more time, so I'm not going to get into that right now. Um, yeah. So yeah. So let's close the loop back to the very first question. Which agent spent what? Um, yeah, yeah. I forgot to do one more demo. Sorry about that. I'm going to initiate another agent. I'm going to call it scraper and give it a budget of 200. So it's going to be very simple. Node pod.js scraper 200. Oh, provision scraper 200. Yeah. Yep. So now I have two agents in parallel. One agent trader that has no budget at all, and the second agent is scraper that has a budget of 200. Um, so let's go back to the very first question that we brought up today. Which agent essentially spent what? And what I'm going to show you over here is just I'm going to show you in one simple command how you can pick that up. So node squad.js report. So yeah, we have two agents, agent 4 and agent 5. Budget 500, spent 40, remaining is 460. And are they both linked? Yes, they are. Let me quickly show you guys this function as well to show you that everything is fully on chain. Yep. Oh, here we are. Um, so yeah, we're essentially using get context info, which is a function that queries this information off chain, on chain, and yeah, like the whole point is the whole point here is that like to read each agent's ledger, it calls get budget as that agent. So get budget is from the Coco contract. Each like yeah, you're essentially calling your get budget function as the agent because you are the primary user. It builds each agent's own wallet and asks that contract why per like asks that contract for that information. You may ask like why per agent? Because remember that the state is per account. There's no like list all users function to call because there's no shared table to list. Uh, the little .squad.json file you might notice is just a local convenience map that maps friendly names like trader to their index numbers. It is not on-chain state, and the chain works fine without it completely. So yeah, this essentially answers the question we asked at first. And yeah, that's pretty much it for the demo and the session. I know today was probably like it was a little shorter session, but it was a little conceptually dense. So I'm gonna wait for a couple of minutes in case you guys want to ask me any questions. But this is the end of the session. I'm just gonna talk a bit about the bounty. Um, so as usual, this repo is going to be uh, published on the Moi webinars repo. If you guys, I'll upload it myself on the Luma link very soon. The first bounty, as always, is if you build along, if you did if you essentially build the same kind of app as I built so far, and actually um, tried it out on chain, um, you will be eligible for a 500 token grant, and this is open to everybody. Right now, like Sanjay and Kishore are probably are on the top of the leaderboard, which there is also going to be a leaderboard coming on soon. But yeah, so you're going to be eligible for a 500 token bounty right here if you guys just built what I've built so far. And for the $15 cash bounty, which only goes out to one person, um, the criteria is going to be very, very simple. Essentially, you guys gonna have a week to do this. The person to build the best, use case of like a sub account using an agent, using a real life agent, and actually showing that all the provenance and the like the authority is stored on chain, wins a $15 cash bounty. It's going to be $15 in USDT, and yeah, this only goes out to one person. The submission criteria for that is you can submit on the form, and you have to drop a message on our Discord as well. Discord's like developer chat. But this only out for one person. It's a very, very simple task. But obviously only the best is going to win. And yeah, that's pretty much it from my side. Let me know if you guys have any questions about the session itself or any logistics about the bounty, and if you guys have want to learn anything more about it. So yeah, thank you all for joining. I'm gonna wait for about 5 minutes in case anyone has any questions. Yeah, Sanjay. So the first question is about the bounty. Um, so essentially, the first bounty is a token bounty, where if you just essentially build out the same app as I built out in this session, which is just the which is very simple app. You essentially create a few dummy agents, and you create like sub accounts and inherit a logic for each of those agents, and just show how exactly works. um, the second bounty, which is going to be for $15 cash prize, is that you use a real life agent that you use on a day-to-day basis for any particular task, whether that's like a web search agent or like any kind of like coding agent, or any kind of agent that has any kind of like that requires some kind of provenance. um, I want you to essentially build an app that um, like you essentially create a sub account for that agent using context inheritance, and you show like different steps of provenance. So suppose your agent does task A, you show that that task has been recorded. So for example, when I did I initially set the budget, and then I hit send. I essentially hit spend 500, right? So that was an action that was taking place. So if you can do the same thing with a real life agent, it's not going to be very, very easy. It's a bit of a thinking task as well. But yeah, it's a bit of an open ended one right there. And with regards to the agent skills SDK, yes, we just got it approved yesterday, and that will be live very, very soon. Sorry for the delay. Okay, guys, I'm gonna end the session then. If you guys have any questions, you know where to reach me: WhatsApp, Discord, Telegram, anywhere. Thank you so much for joining the session, and yeah, have a nice day. Take care.